So the first thing we're going to talk about is how to prove rhombi using coordinate geometry. And the first step is you prove it's a parallelogram by making sure the slopes are the same for the opposite sides. And then you prove that all sides are congruent by using the Pythagorean theorem or distance formula, your choice. And so on example 1, they want us to prove nui with the following coordinates. Prove that nui is a rhombus. And so before we prove it's a rhombus, you need to prove it's a parallelogram. And so I would go ahead and plot the points. So you have 1, 5 for n. You have negative 1, 2 for e. 1, negative 1 for w. And then 3, 2 for y. And so what we need to do first is prove that from here to here and from here to here is parallel. And also we need to prove that from here to here is parallel from there to there. And so that's how we're going to prove it's a parallel. The first thing we'll do is we'll look at the slopes. The slope of en, so how far is it from here? You go 1, 2, 3 over 2. So I would call the slope 3 over 2. And then doing the same thing for w to y, I go up 1, 2, 3 over 2. So I'd say wy is also 3, 2. That's a good first step. We made sure that en and wy are the same slope. Okay. So I might even, just for the better of the proof, because to prove a parallelogram, we need to prove that en equals wy, and we just did. They're both 3 over 2. Now we need to prove that the slope of we equals the slope of yn. And so I find the slope of we, this one's going down, so it's going to be negative. So if I start here, I go down 1, 2, 3 over 2. That's negative 3 over 2. And then going from n to y, it's 1, 2, 3 over 2. So I just showed in my proof that both pairs of opposite sides are parallel. And because they're parallel, that's enough to prove that they're a parallelogram. So if they said, is nui a parallelogram, you'd say yes. Now I also need to prove, looking above, that all sides are congruent. And so all sides congruent, we'll call that the proof. And so how do you find the length of the side? And this is when we go back to Pythagorean theorem. And so we have right triangles here, and we can use that to find the hypotenuse. So like from here to here is 3. And then from there to there is 2. And then I can use Pythagorean theorem to find how far it is from e to n. So en, and if I had different software, I'd put a little line over there to say line segment. En is equal to the square root of 3 squared plus 2 squared. Remember, a squared plus b squared is c squared. At the very end, when you're solving for c, you take the square root. So I'd get square root of 9 plus 4, and that equals the square root of 13. And I'm going to leave it as square root of 13. Now, to find the length of ny, ny is also a 3 by 2 leg, so the hypotenuse is going to be the same. So I know that ny is also going to equal square root of 13. Because it's the same triangle. It's still a 3 by 2 triangle. So it has to be square root of 13. Anytime you have a 3 by 2 right triangle with legs 3 and leg 2, the hypotenuse is going to be square root of 13. wy is also 3 by 2 to get the hypotenuse. And EW is 3 by 2 to get the hypotenuse. So, based off the picture, I would say that ny equals square root of 13. YW is square root of 13. And EW is square root of 13. So En is equal to ny is equal to YW is equal to EW. So this is enough information to prove that Nui is a rhombus. So to prove a square you have to prove it's a parallelogram, and then prove it's a rectangle. Proving it's a rectangle by the angles of opposite reciprocals show that you have 90-degree angles. And then you also need to prove that it's a rhombus by showing all 4 sides are equal. So you're going to plot the points, prove it's a parallelogram by looking at the slope, prove it's a rectangle by making sure the slopes are opposite reciprocals, and then you're going to measure each side using Pythagorean theorem, and that'll tell you if all sides are the same. Remember, a square has 90 degrees and all sides are the same. So we're going to first prove that this is a parallelogram. And so if I look at the slopes from R to A, it looks like you go up 1, 2, 3, 4 over 2. And the same thing is from here to here, you go up 4 over 2. So the first thing I'll say is that RA equals YE equals 4 over 2 equals 2. Rise over run, 4 over 2. You go up 4 to the right 2 on both. So that's the first step. Now, if at any point this wasn't true, I could stop and say, hey, this is not a square. I could do the other side now and measure from R to Y. That'd be down 2 over 1, 2, 3, 4. So this is 2 over 4. So RY, and I really should say slope of RA equals slope of YE, just like slope of RY and we'll see, we know RY is 2, or I'm sorry, you go down 2 to the right 4, so since you went down, that's negative 2 over 4, which is negative 1/2 if you reduce it. And then also going from A to E, you also go down 2 and over 4. So the slope of AE is also negative 2/4. That's the first part of the proof. We just proved that they are parallelograms by the slope. To prove it's a rectangle, rectangle means that 2 and negative 1/2 are opposite reciprocals. So if I take 2 over 1 and I flip it, I get 1 over 2, and you change the sign. So I would say 2 and negative 1/2 are opposite reciprocals. That's all you have to say. And because they're opposite reciprocals, that means they're 90-degree angles. They're perpendicular. That means that's another step to have a square. A rhombus does not have to have 90-degree angles. And then for the rhombus proof, in all actuality, I have triangles that are leg of 2, leg of 4, leg of 2, leg of 4, leg of 2, leg of 4, leg of 2, leg of 4. So since they all have the same legs, of course they're going to have the same hypotenuse. So that's one thing you could say. But just to make it a little more exact, we know that AR, if you do the Pythagorean theorem, would be the square root of 4 squared plus 2 squared, which is 8 plus 4, which is 12. No, I'm sorry, 4 squared is not 8. 4 squared is 16. And then 2 squared is 4. So that'd be square root of 16 plus 4, which is square root of 20. And because AR, RY, YE, and EA are made up of the same legs, I would say that AR equals RY equals YE equals AE, which equals square root of 20. And using those 3 facts, that's enough to prove that the year is a square.